Hello everyone, welcome to the good stuff we've been doing. Here we got a nice problem on algebra, simplifying algebraic expressions. Where we also simplify this. They said x plus. I will not even mention it. There's no point. It's too long. So, but let's just stop staring at the river and dive into the river and explore. But before we dive in, we have to check with our feet before we destroy and break our neck. Here we have to notice that we cannot just take everything out and write it completely. Let's simplify the numerator first and then the denominator. For example, here for the numerator, for this part here which we are concerned of, here the numerator part will tell us that we have 1 plus x over 1 plus x. So x 1 plus x has to multiply this, everything boils down to 1 plus x. Then we have plus xt all over 1 plus x. So here we'll be having 1 plus 2x all divided by 1 plus x. So let's see what the denominator part tells us. Well, for denominator, we'll be having, say, x plus 1 over 1 plus x, and just as before, we'll be having x has to multiply 1 plus x, then we'll add with 1, and then we'll have 1 plus x. This is what we did here, though there's no point of 1 multiplying 1 plus x. There's no point of writing 1 multiplying 1 plus x here, since it's just 1. Everything boils down to x plus x squared plus 1. So it's x plus x squared plus 1 all over 1 plus x. Or you may even write this, we can write this as 1 plus x squared all divided by 1 plus x. In maths, it's always neat if sometimes the powers are either in ascending or descending order. Like this is x to the 0, x to the 1, x to the second power. So this is this part here. We have done this part here. So if you put everything together, we will notice that this expression we have here, which is 1 plus x over 1 plus x all divided by x plus 1 over 1 plus x, is just the same thing as we pick 1 plus 2x all over 1 plus x. Then we divide by 1 plus x squared over here all over 1 plus x. And of course, if we notice that this is same thing as 1 plus 2x all over 1 plus x multiplying by 1 plus x all over 1 plus x squared, then we can just cancel out these guys and notice this is equal to 1 plus 2x all over 1 plus x squared. So we have observed that the part highlighted in blue is actually equal to 1 plus 2x all divided by 1 plus x squared. Now what about this guy here? This is how we proceed. This x plus 1 squared minus x squared all divided by, I'll say that it's 1 plus x squared. Why not? This is what we've been doing, so why not continue it? So this is, there are many ways you can evaluate this. You can just write it as x plus 1 minus x, then you'd be having x plus 1 plus x all divided by 1 plus x squared. Why did I write it this way? Well, in this channel we always favor that we use this identity, a square minus b square is a minus b all over a plus, it's all multiplied by a plus b. So we like to just always use it in this channel. So the next thing I'll do now is to just write this as this s cancel out, that this s cancel out, I'll just have 1, so everything is s plus s. So we'll get 1 plus 2x all divided by 1 plus x squared. But if you don't like this method, you may just write this as, this will be x squared plus 2x plus 1 minus x squared. So s squared will cancel out s squared, it will be all over 1 plus x squared. So we still get the same thing, but probably using a different method. But I still prefer this one that involve us using difference of squared. This one that involve us using difference of squares. So what we have here is that we already have the denominator. So we have this part divided by this part is same thing as 1 plus 2x all over 1 plus x squared, all divided by this second part here, 1 plus 2x all over 1 plus x squared. Are you thinking what I'm thinking? Well, yes, everything cancels out. So because we're having 1 plus 2x all divided by 1 plus x squared. Then we are going to multiply by 1 plus x squared all over 1 plus 2x. Yeah, so everything now boils down to just, there's no point in even canceling. We'll not even try it here because everything is just so neat. We don't want to ruin the identity. So we have this equals to 1. So we have a very neat, nope. We have found a very neat solution to this beautiful problem. Mostly because why I picked this problem to solve is because the answer is 1 really. And not just that one, there's the method to the solution is just very astonishing. The problem looks intimidating at first, but everything just boils down to a neat 1 as the answer. Not a J, but a 1. So if you like my content, please subscribe to the channel. Thank you for watching and have a nice day.